So we have our CH3CH2 plus group. So this benzene attacks it over here because it's positively charged. The benzene attacks it over here. We have to show this curly arrow to show the direction of movement of electron pairs. Then we get our not so stable intermediate. Our benzene molecule is stable, our intermediate is not stable. We get our intermediate where my circle is broken. I have a positive charge and I have CH2, CH3 over here. I have H over here, and I want to make my molecule stable again, so this curly arrow to show the movement of these electrons towards the positive charge, and then I again get my good old stable benzene molecule. The only difference being that it's attached to an ethyl group. So I get my benzene molecule, it's attached to my ethyl group, and I have successfully alkylated my benzene. So the type of reaction is called Friedel-Crafts alkylation. The reaction mechanism is electrophilic substitution. So, and we use AlCl3 catalyst. So as I was showing you before, my equation disappeared, so I'll write it again. I was showing you that CH3 CH2Cl. Here my CH3CH2 was my R group, as shown here, was reacting with the AlCl3 to give. And also I've also forgot to add my H plus over here, very important. The byproduct of this reaction, you will lose marks if you do not show that H plus has left this molecule. So please remember, don't forget like I did. And we also have, so in this reaction we have the complex AlCl4 negative, and this is this, and with this we also get a CH3CH2 plus group. Okay, so we have this electrophile now, which is the CH3CH2 plus. It's called electrophile because it is hungry for electrons, as they call it. It wants electrons to get rid of this positive charge, and that's why it will react with benzene. So we have the CH3CH2 plus. Now I want to get my catalyst back. I want to get AlCl3 back. So what happens is that the H plus will react with the AlCl4 negative complex. I'm sorry, the AlCl4 negative complex. To give HCl plus AlCl3. So yeah, so we have got a catalyst back, and it's not used up, and that's why it's called a catalyst. We've done the electrophilic substitution, we have alkylated the benzene molecule, and this is the reaction. Let's move further. So Friedel-Crafts acylation of benzene. So first we did Friedel-Crafts alkylation of benzene. Now we'll do Friedel-Crafts acylation of benzene. Now, as you see the name, it suggests that there must be some similarity to alkylation because it's the same name, just the alkylation replaced with acylation. So the reagent in this case is acyl chloride. There it was RCl, where R was the alkyl group that we wanted to attach. We did CH3CH2 as our R group, and in this case we use an acyl chloride. So let's take as an example let's take ethanoyl chloride. So acyl chlorides are a particular class of